Hello, and welcome to another exciting episode of Cooking with Unity. Did you see that thing go...
I
Wait,
did.
what the heck?
It's doing it again.
Okay. I don't know why it's doing that. I don't care. I do care, actually, deeply, but I'm going to ignore it.
It's doing that on the camera, not on the
Yeah, I
entire
know.
screen.
I know.
That's
We need
good.
to not
That's
worry
good.
about it.
All right. Welcome. I'm here with people.
I'm a people.
Let's get started.
My name's Phil, and I'm a people.
It's true, he is.
I've seen him. Not on the show, though.
Yeah, you
Only
know,
in the
maybe
comments,
once,
yeah, okay.
Once or twice.
All right, what is it doing? Why is it doing
Don't worry
that?
about it. Just main screen turn on.
All right, main screen
What you
turn
say?
on. All right.
It's you.
How are you, gentlemen?
All your base.
Our belong to us.
We get signal.
You have no chance to survive. Make your time.
Move Zig for great justice.
Yes. Okay, now that we've exhausted that, it's not exhausted at all.
All right. Oh, yeah. We're on 2D Thursday. We can do my layout thing. 2D shooter vertical. All right. So what were we doing last time? So last time we were implementing a new lasery system thing. And I think did we make a test level for this? Yes, we did. And last time we actually ran into something that was freaking us out where it was doing something strange. And after the show, we actually confirmed that this was a bug in Unity. It was creating another game object that was being found by our find game objects with tag. I had run into something similar with this later, similar to this on another project. It's probably some temporary object that Unity was creating for tracking something that just was being set wrong for whatever reason. Now, we're running Unity 4.5 this time, so I'm interested to see if the bug is still there. So let's give it a look-see on this. So what we had going here is, once we hit play, it creates this this beam between the characters right now. And what our bug was, and I'm going to turn off the maximize on play. And what our bug was is if we selected something in here, it would add an object. Ooh, that's promising. Yeah, looks like it's not doing it anymore. Yay, they fixed it.
Click in the game screen and move it so you can move around. And highlight enemies, the different enemies.
If you don't
Killed myself. Yeah. Alright, highlight the different enemies. Yeah, before what we'd see is if we highlighted anything in here, it would add something at the center here and it would shoot another line between them. So yay! Looks like that's either fixed or we're not seeing it anymore on this project for some reason. Which either way could really happen, but...
Yeah, for reasons unknown, it's working.
Alright, cool. So we got this going with the beam thingy. So let's look at what we're doing there and do some more
We need to get some
work
Bezier.
on this. So Bezier laser. This one uses the Bezier laser script. All right. I forgot to open up Mono Develop beforehand. All right, Bezier laser. So right now what we're doing is we're finding the nearest enemies, and then we're going to the next enemy, and then we're going to the next nearest enemy, and then the next nearest enemy from each of those points, and we're connecting in we're connecting the beams to all of them. We're going to be changing that so that it has some more constraints so that it doesn't just do that, but we're also going to want to make it so that like the beam itself varies and curves a little bit as it goes through. So what should we do first? So right now the beam will go to whatever's closest to the player, then whatever's closest to the next enemy, and so on and so forth. And so if we keep adding enemies, it will just keep doing things. So like we could just duplicate, and drag things out, and you'll see that we'll get more enemies connected up. And if their positions change in certain ways, you'll see the beam changes as well. So right now we hit things even if they're behind us, as you can see, and we hit them no matter how far apart they are, which we're probably going to change that. But for right now, let's see if we can make it so that the beam actually does a little bit of a curvy thing, considering we have a Bezier curve being calculated anyway. So right now we're doing the quadratic points. So if we wanted to add a curve to this system, let's look at our points here. If we go into the inspector on the player Bezier laser. So these are probably going to be tweaked constantly. Yeah, these are constantly being updated. So I probably can't tweak them right now. Yeah, while our script is active. So I'm going to turn off our script for a moment. And we're going to see what changing these values do.
Turn on continual recalculate.
Oh, thank you. Alright. So
That's fascinating.
So wait. So P0 and P1. So P0 is the initial point. P1 is the end point, or is it like
It's the pull
direction.
point.
just the pull direction? Okay, cool.
And P1 is the endpoint. Or P2 is the endpoint.
So right now we're saying P1 as the midpoint. That's what we're doing, right? Yeah, we're using vector3.lerp here to get the midpoint. Now, the way that works is if you give vector3.lerp 0.5 for the time, you'll get the halfway point between 2 points. So this is what we should actually be changing the position on if we want to make the beams have a little bit of movement to them. So what I'm going to do is I'm going to try something really basic first to see how it looks. I'm just going to multiply this by is that the whole thing with the vector3 lerp? So this is the position. I'm going to add, rather, random dot inside units circle. Hopefully this will be the right coordinates that we want for this. It might not be, though. Random inside unit circle. And let's see how this looks real quick. Ambiguous following methods and properties. Let me quit this out. So that's because this is a 2D thing, so we're going to do vector 3 on it. And we're going to hit save and hit play. There we go. And now we've got a little fancy rando beam. It actually doesn't look too bad, even as is. If we actually made it less pink and more of like a lightning type texture thing, that would actually work pretty well. Looks kind of like, looks kind of like an electrical thing. It's not. It's more of a curvy thing.
Looks like a rubber band.
Looks like a rubber band. Okay, it looks like a rubber band.
I think at least it does, because it's like what happens when you hold one tight and then smack it and it starts doing its vibrating.
Yes.
It's kind of what it looks like.
We could do this on all of the points as well, as opposed to just the midpoints. And that might free up a little bit here. Just curious what that'll look like. So,
if you, well, I was just thinking, if you use the cubic, then you'd have 2 center points, and if you're randomizing that, then I'm not sure exactly what it'll look like. You might be able to steer away from the rubber band.
Yeah, I think
don't know
using the cubic one would probably be a little.
All right, let's try it.
like
I don't know if it'll look like lightning or not, but because it'll still be curving, but you might get some interesting curves.
yeah, let's give it a look. Give it a look. We don't necessarily need it to look like lightning either. What we were basing it on wasn't even based on that, but I'm interested in seeing what we can kind of do with this. So
Yeah.
let's go ahead and drag the quadratic or the cubic version of the Bezier chain.
I had to think about it for a couple seconds too. I was like, wait, which is the one?
Yeah,
with the...
yeah. Well, it's the one that we don't have on here. That's the only reason I knew. I'm like, the quadratic, and then I read this. I'm like, no, the cubic. So I'm going to disable this one, just for now. And we're going to use the same types of settings.
So
we're going to
yeah.
use line renderer, I guess. Do we still need that? Does it create a new line renderer, or is it all...
It uses the one that's on there.
Good,
Or
all
it
right.
should use the one that's on there if there's one on
Yeah,
there.
good. And that's the only thing we have to check. All right, cool. So what I'm going to do now is we're going to want to change. I'm just going to comment this one out in case we want to go back to it. Cubic Bezier chain, and then find quadratic Bezier chain. Get rid of that. Wait, quadratic Bezier points. Beam chain. Okay. Cubic Bezier points, probably.
Yeah.
I guess I could have just replace quadratic. Let's do that. Replace quadratic with cubic. All. Just do it. Yay.
And the only thing I know that we need to change is we're gonna have to add that extra.
Yeah, the
when
extra
we're creating
point.
the
So,
point, yeah.
so in this case, cubic Bezier points equals new cubic Bezier points, and then so this one probably is a slightly different definition that has 4 points, right? Yep. Leave, start, approach, end, and end. So I'm just going to duplicate this middle thing here, inside unit circle included.
That middle thingy.
Yep, this middle thingy. And we're just going to paste it and put another comma, call it good, and see how that looks. That's a huge... I'm going to actually hit enter on these so that we can actually read what's going on a little bit.
Yeah, that would be nice. We don't really need to read what's going on.
Save. Still a lot to read.
Yes, it is.
Alright, so we hit play. Oh, and it started working immediately. And yeah, it actually it made it so that there's actually like multiple points. So it actually kind of has a little curve to the inside. I actually really like the way that looks. So just to explain what's going on here, before we just had a midpoint, now we're adding random inside unit circle, which basically is adding a random direction in any direction up to 1 point away from where that point was. Now, we could adjust the amount by just multiplying in a scalar on top of that, so we could just do times like 0.5 and it would be half the amount, or times like 10 and it would be up to 10 units wide. But right now it actually looks pretty good, so I may just keep that.
We could do it based on the distance between between P0 and P.
Oh, where like becomes more erratic as it's farther away, or more concentrated, or something, or
yeah,
that's actually kind of an interesting idea.
Yep,
I like that.
Yeah. It would have to be more erratic if it's farther away because, well, maybe not.
All right. So, what are we gonna do? We're going to.
I need some wah-wah sound effects.
A wah-wah sound effect, yeah. Let's actually change it so that this thing, when we hit it with the laser, let's change it so that this thing only goes like forward.
There is a thing that says, "Yeah, I'd like to see some programmatic lightning bolt effect." That'd be cool. I'm
Yeah,
sure you can.
yeah.
If we are actually trying to curve these, it would probably look more like that.
Yeah.
To be completely honest.
So, yeah, if we wanted to curve these...
If we didn't want to curve them, then we could get the sharp points like a bolt, and I
Yeah.
think that we'd actually do a pretty successful looking lightning bolt.
So you want to actually just do it less like the curved stuff and more like just a...
straight line with some deviance, basically, and some hard angles.
So, what am I doing? I do like how this looks, though, when we get, like... Especially when we get close. That makes me actually want to do... Let's actually try that. Let's do the distance and actually feed that in as a multiplier into the into this equation here. So, do we have a distance between the enemies? So right now we put the enemies in order. We get beam transforms.count. So what we're doing now is we're getting all the enemies. We're getting the distance here. Are we storing the distance anywhere? Position. So... No, we're just figuring out the order. Okay. the easiest way to do this. So let's do a dictionary or something. Let's see, public dictionary. What are we doing? This would probably take a game object, and we want it to return a distance. So that would be a float of distance. All right. So we're going to call this enemy distance, and we're going to equals new dictionary game object enemy game object float. And what are we going to do with this? What we're going to do is enemy distance equals new dictionary game object float. So when we get the enemy distance right now we're just curious about what the nearest enemy is, and then once we determine that the next nearest one is in there, we add it to this beam transform. So what we're also going to do is we're going to add to the dictionary here, it's called enemy distance, and we're doing enemy distance dot add enemy distance dot add enemy distance dot add. And we add the nearest enemy, which is a game object, and that's our key, and we add a float value, which is the nearest square distance. And actually, we can go ahead and do the square root of this. So we'll do mathf dot square root nearest square distance. So this saves us the square root operation still in a lot of cases, but when we finally find the enemy, we actually do want its distance information, so we're putting it in here. So now we've got this information that we can use. It should be in the same... Oh wait, it doesn't have an order, does it? So it's not in order of the beam transforms, and we could have done it that way. We could have done it as a separate list and then just kept them in the same order and then go to the same thing.
Yeah.
But what we're instead going to do is we're going to use the beam transforms. Beam transforms is not a game object, is it? It's a list.
Mm-hmm.
We can get the game object from that though. So we're going to get the game objects from there and then use that to reference into our distance. So what we'll do is we will add... I'm going to do it up here actually. So float distance equals enemy distance. We're basically unpacking the data we just packed up above. Enemy distance, and we give it one of these, and we do beam transforms I dot game object.
Yep.
Now we have our distance information for that particular game object, and then we can use the distance here in our equation. Times distance times distance. Alright, file save. And let's see what this looks like. Oh, I messed something up. Element with the same key already exists in the dictionary.
Ah. It's trying to insert duplicate objects.
Yes, it is.
Exciting.
So why is it doing that? So while all enemies count is greater than 0, we do...
Just refreshing.
Yeah. Distance.add and transforms.add. All enemies.remove.
Are we clearing the dictionary every time or something?
Oh, good call. Alright, so this happens every frame.
Mm-hmm.
And so that means that we're adding to it. So the first frame it probably works just great.
Yeah.
But then after that, it doesn't work so great. So, where do we clear this? We'll clear with the other beam transform. So what we're going to do is we're going to add enemy distance dot clear. I didn't explain this very well, so I'm going to go through it in a second here. Hit play. I just want to see if it works first. Oh, still getting the same issue. Did I save? I did. Oh wait, what was that? Given key was not present in the dictionary. How is that possible?
It's not finding the key.
Is that for the player?
Oh, probably.
The player
is the first one. So what we want to do is so if we'll do a check. If enemy distance dot contains key, and we put this in there, in there, and what are we doing? So if it contains that, then we do this, and if not, we don't do anything. Oh wait, but that will mean that we
So
have
just
to
take
have a
float
distance.
distance out and set it equal to
Yeah.
1.
Yeah.
Float distance equals 1, and then we get rid of the float declaration here.
Do you have to say 1F?
No.
Probably not, but I'm going to. Actually, no, you probably do.
Think so?
0, I think. Well, here, actually, I'm curious. Let's find out. Let's set this to 1 and see what happens. Save. Play. It works. So float distance equals 1. I still want to do this though, just to be explicit. So that looks like it's kind of doing maybe the opposite. Oh wait, okay. So the distance is
Off by 1.
off by 1.
There's squiggly lines everywhere.
I like that. Oh god, I forgot that I can actually die from these things.
Mm-hmm.
So yeah, what am I gonna do? All right, so we're off by 1. So the problem is, are we not getting the distance to the player? No. Okay, so the first time the distance is 1, but it shouldn't be, should it?
Should probably be 0.
Think so?
I don't know. Just a guess.
I don't think that's going to fix the problem though, because we've got.
Well, I think the first thing we really need to do is insert the player into the dictionary as the first object. Since we're using it as the first point, we're iterating through points.
You're right. So, how are we doing the player in the first place anyway? Because it should be in here somewhere.
It's in the...
Oh, add transform. Here it is. So beam transforms dot add transform. So what we need to do is, so we actually need this value to be 1 back. Like this, these distances. So the first distance should be associated with the player, and then all subsequent distances should be associated with the subsequent enemies. What does that mean?
So we can do that because the previous object has already been added to our...
So off by 1 actually looks pretty good. Yeah.
To our beam transforms. So we just add beam transforms dot count -2 as the key.
Okay, all right. I see what you're saying. All right, so after the first one,
You said the off by 1.
yeah, it does actually
cool.
look pretty cool.
I agree.
Beam transforms dot add transform. So the first one's player. So I guess we could just add. Oh wait, we need to calculate the distance the first time. So the first one has to go to the player. So you said, what you basically said was something that instead of adding nearest enemy, we add beam transforms.
Beam transforms.
Sub.
Beam transforms
I minus
dot count.
or beam transform's got to count.
-2.
Count.
Because you're adding right above, so that would give you the
So
player
actually,
the first time.
Let's do it one above, so I don't have to do -2. We'll just do -1. Oh, and this will just work. Yeah, you're right. Yeah, that'll just work. So what has happened here is we've already added the player here. So beam transforms that count minus. Wait, would it be -1 or
Count would be 1, so it would be
yeah,
0
you're right.
this time.
You're right. You're right. So this is right. Let's see how that works. I may just fix all of it. That's awesome. If it worked. Oh yeah, it needs to be dot game object. Save. Play. Sweet.
But we're still getting the.
So I think we're gonna have to like divide it by 2 or something.
Yeah,
'cause
yeah.
that's
We're
going
gonna need to
crazy.
scale it something. Or do we want to get crazier as you get closer?
We saw what that was like.
Yeah, I guess that's true. Well, no, we saw what it was like when you got further away, but they were still close together. Yeah, I think this is about right, actually. But let's put a scalar in there just so that we can adjust it.
Mm-hmm.
So, public. So, this is the enemy distance. We actually don't need that to be public. I'm going to make that private. And let's do public float beam craziness equals 1.0f. And then we will multiply in beam craziness here. I couldn't think of a better term for it, and it actually seems like it might work. So if we go onto the player Bezier laser here, we will
Adjust beam craziness.
adjust the beam craziness. So this is in beam craziness here. So if we bring this down to 0, it's nothing. And actually, if you go negative, it goes crazy again. So, but yeah, and we can make it even crazier. We could just make it go across the universe if we wanted to.
Let's not do that.
So let's make it like 0.5. Is that what we were discussing?
Whoa.
Ah,
Whoa.
I don't know what. That's not a number. All right.
That's not a number.
Nan.
Yeah, I like that. And then we'll make it so that the beam breaks at like around this point. So
Yes, invert it. Closer equals crazier.
We could change if you wanted like a lightning kind of effect. Not that we're still going with that.
Well, it seems like I would be interested in seeing that myself. So it seems like we just need to stop the curving.
So what were you gonna say?
Well, I was referring to a different aspect of it. Also, we could have it so that it only updates every instead of every frame, have it only update every
Other frame or something?
like
or?
5 frames or something, so that it looks so that you can see it a little bit longer and it like snaps from one to the other rather than looking like it's
Just random.
And
Yeah.
if the number of frames that it stays is long enough, we could also have like a very quick fade in or something on the line, so that the line like pops in and then fades out really quickly before popping to the next position or something.
So I don't know if I like the idea of the persistence thing, just because I don't know, electricity always looks really random to me when I see it, just because it always picks, like if you have a really high voltage, I guess that's not true, like if you have like the Jacob's ladder type thing, you sometimes have a coherent beam. I don't know. In the case of, actually, we can probably make it more beam-like. If we can probably make it more lightning-like just by limiting the number of subdivisions per section. Honestly, we could probably like this, make like just 3 and 3, and then hit play. And that didn't do that much. Oh wait, it reset itself for some reason. 3, and it's going to change again. All right, what did I do that makes that happen? Are we saying that in Bezier laser or something?
Might be.
So beam So Bezier chain, beam chain, that doesn't affect the... Alright, so if subdivision points equals null... Maybe that's what happened. For some reason, subdivision points was suddenly null. What happens if I hit play and then change it? There we go.
Neat.
So now it's more lightning-like already.
Turn down the craziness a little bit too.
Alright, let's go to our craziness. And oh yeah, I didn't save the 0.5.
It's kind of neat.
Yeah, I kind of like it. If you ever want to invert the craziness, like someone wanted, it's actually just as simple as changing the last operation here. Instead of being times beam craziness, you just divide it by beam craziness. And that should, I think,
theoretically invert the craziness.
So, no. I was wrong. Or did I not save? I probably didn't save. Nope, I saved. I'm doing something stupid. Oh, divided by 1 really doesn't do a whole lot, does it?
No.
So let's look at... So that's actually not... That's not going to do it at all. I wasn't even thinking. So in order to actually fix that, it would be... Okay, so the distance would have to be... like 1 over distance. Equals enemy distance divided by... I guess we could divide that by beam craziness. I'm overthinking this, aren't I?
Probably.
I'm not going to worry about it for right now.
Yeah, let's not worry about it right now.
Alright, so we've got these beams.
But let's get the subdivisions again up so it looks like a lightning.
Alright. Subdivisions up so it looks like the lightning.
Which was, I believe, in the editor, right?
Yeah. Subdivisions. So, oh yeah, sorry. I didn't save that, did I? All right. Nope. So, oh yeah, but we can't save it because for some reason when we change it, it changes back. So,
try turning on continual recalculate and setting it, and then now turn it off.
It still didn't work, but let's try. Okay, both steps. All right, 3. Turn off continual recalculate. All right, still.
Maybe it is being nulled out when it runs or something.
It seems that way.
Could add a debug.
Yeah, let's do it. There. So we're looking at a null check. Null. Alright. Debug.log. Subdivision points. Actually, I'm just going to type it out. Subdivision points is null. Alright, file save. Hit play. Alright, so I did say subdivision points is null immediately. So check recalculate is called in update, and it's also called in onDraw gizmos. And subdivision points is defined. Go to declaration. Subdivision points. Find references. There's quite a few. All right. So where's subdivision points initially set? Recalculate subdivisions is one where it's set. Is this all in recalculate subdivisions? Yes. So I think we just need to make sure that we do a recalculate subdivisions before we do our initial check recalculate.
Can you scroll down just slightly?
Yes.
Up a little bit.
All right.
Can you search? Oh, never mind. You could probably just add an if statement in front of subdivisions per section and check to make sure that that's not.
Check to make sure that's not what.
Wait, scroll down a little bit. I thought I checked for that separately, the subdivisions per section.
What's special about the subdivisions per section?
That's what's changing.
Well, it's what's changing, yeah, but it's changing here because the subdivision points is null, right?
Yeah, but I thought that I checked the subdivisions per sections. Oh, I do check it. It's in. Wait, scroll down.
Okay.
It's in the actual function that recalculates the subdivisions, I think.
Okay.
I think it's at the beginning of that function.
It initialize it was an subdivision index 0.
Subdivisions per section.
Here.
This one.
If it's less than 1, then it equals 1.
All right, here. Let me just try something. So
You might be able to comment out that section where it's set to 16 because I think it checks that boundary before it calculates the subdivision. So actually comment out the subdivisions, number of subdivisions equals 16. Just comment that out.
this out. Just see if this works. Okay.
I think the need for it there was deprecated.
All right, so if I go to the inspector now and we do 3 and 3 and then we hit play.
You don't actually change total subdivisions.
Yeah, it worked. Oh, you don't
It
change.
worked.
So that's automatically calculated. Well, good. It automatically
That's just to
calculated
show
itself.
you.
Sweet.
How many?
Yeah, if you
All right,
have
so
a bunch of
you
points
didn't.
and you
That
have
was
a bunch of.
that was a null check that's no longer needed then.
Yeah, because
Okay.
it's checked to make sure that you don't set it lower than 1 and you don't set it over like 100
Okay,
or something.
cool. So
Oh,
it's
okay.
gonna
If you
get
do
rid of those
want-
lines.
If you do want it over like 80 or over 100 or whatever, and you find out that it keeps setting it back to a lower number,
That would be 1.
then it's because it's actually in the script to make sure that you're not like dragging the
They can go
integer in
crazy,
the editor
yeah.
and you don't accidentally drag it up to like 50,000 or something and then have it end up slowing down the Unity editor to the point where you have to force quit.
Can we get rid of bring the craziness down a little bit? That was never saved.
All right. Yeah. Thank you. That was the thing. One thing I could save, and I never saved it. 0.5. I'm gonna go ahead and apply this to our Bezier laser prefab. Actually, it's part of the player prefab, I guess. So, wait, I didn't.
Whoa, that.
Oh, I'm
we're
using
dividing.
divide. Yeah, I'm using divide. All right. Wait, no, I didn't save it. Save. Does that work now?
That seems.
Yay! All right. Less crazy. Looks good. All right. All right. We got 20 minutes left in the show.
Do we want to make sure that it just jumps to enemies in front of the player?
Yeah, let's do that. Let's do that. So, where should we be making this check? So now we have to. Right now, we're going through all the enemies, and no matter what, each enemy is getting hit. So we have to figure out a place to actually place some logic.
Right when we're inserting it into the dictionary, probably.
Well, no, because
Right before, I mean.
It would have to be in
wouldn't.
the-
It would. We don't want it in beam transforms either.
It
So
has to be in the while loop when it's checking the enemies.
Yeah.
You have
Yeah.
to make sure that it's not that if at the beginning of the while loop, check to make sure that the
next enemy is a certain.
the enemy you're about to check is
Yeah.
higher in the Y or
Y,
Z.
Y
I'm
coordinate,
not sure
whatever
which
it
coordinate.
is. Yeah.
All right, so it would be the Y coordinate. Because of the way that we set this up, we set it up using Unity's 2D system, so Y is up and X is left and right.
Which I think that.
So,
Makes sense.
so what we're just going to do is we're just going to do a check to see. So we actually only want enemies that are above the player
Above the previous enemy.
or the previous enemy. So we need to check that before we do the nearest distance. And I'd actually rather do it where it's like an angle. So as opposed to just being above, we check to see. We could probably use a dot product.
We also want to limit the distance that it can travel, so
Yeah.
maybe we should put in a few constraint variables.
Mm-hmm. All right, so instead of looking through all the enemies, how about we just look for the first... No, that doesn't make sense, because if there's an enemy that's really far away...
Would a physics overlap sphere save us any time?
It might.
Oh yeah.
Very well might. Yeah, let's just do that. So we'll just check enemies that are within a sphere of the previous enemy. So instead of doing all enemies... So, all enemies. Do we want all enemies still? No, we don't. So, we have all enemies. We don't want to modify all enemies while we're in it. So we don't want to go through all enemies. So this is not... Okay, so we got to change this. We got to reorganize this a lot. I'm going to save real quick. I'm going to actually perforce this, P4V, because we've got things at kind of a stable point right now before we start tearing things apart. And we're going to go cooking with Unity.
Password looks like it could be so long.
It could be so long, but it's not. So, reconcile offline work. Reconcile. And submit. Actually, I didn't save. Hold on. Save scene. Save project. We'll reconcile one more time. Reconcile.
Player prefab.
Alright, so what are we
Just
doing?
refreshing.
We're going to do submit. And we're going to do Bezier curve prefab scene script. So this is lightning beam kind of working. So we're going to tear this apart now. Now that it's kind of working, we're just going to rip this thing a new one. So while all enemies.count is greater than 0, so we don't actually want this as a criteria. We're going to look for enemies that are... So physics has a neat little feature called .overlap sphere. This allows you to check to see if things are close by to the player without having to do distance checking. What were you going to say?
Does physics 2D have like an overlap?
Like box
Circle
or volume or something?
Overlap, something.
Overlap circle.
Overlap. Yeah, they've got a lot of cool ones actually. But we're not using the 2D physics, so we only have overlap sphere. That makes me unhappy now.
Makes me kind of happy to see all of the 2D stuff that they have, though.
All right. Yes. Yeah, it does.
Mm-hmm.
So physics overlap sphere basically allows us to find all objects that have colliders that are within a certain radius. So let's create a public float beam search radius. Let's default this to, what, 5.0 F?
I don't know how much 5.0 F is actually
Let's just do that as a start.
in 2D land.
All right, so for each game object, oh wait, that would be collider. Collider call in physics.overlap sphere, which this should return, yeah, a collider list, and we give it a position. So this first one will be transform.position, and the radius will be our what do we call it? Beam search radius. Beam search radius. So this is going to be all of the colliders, and I missed a thing. No, semicolon. A parentheses.
Yeah,
parent.
sorry.
All right, so we want to make sure this is an enemy though, because we're not checking just enemies here. So actually, can physics overlap sphere take a? it can take a layer mask.
Mm-hmm.
Are the enemies on their own layer?
I think they're on an enemy's layer.
Sweet. Let's do that. So let's create a public layer mask, beam search mask. I'm going to default this to -1. That's a really good one to default it to because it means everything. So your scripts will probably work. But we're going to actually change it so that it is set to just enemies. So this should only find enemies now. So now we don't have to do an additional check. So this, we can assume that anything that we got here is an enemy.
You didn't
And
add it to the function, though. The layer mask.
oh yeah, thank you. Layer mask. That's what I called it, right? Oh no, I called it beam search mask. Beam search mask. Thank you. So now we can assume anything that's in here is in here. That's not really what I wanted to say. Anything that's in here is an enemy. So so now we want to make sure that the enemy is in front of us rather than around us. So what I'm going to do is, I guess we can just compare the Y. Let's just do that. So if col.transform.position.y is greater than transform.y form.position.y. So find in nearby enemies, ensure enemies are above us. So this is just for the player. We're making assumptions here. I'm going to have to change this so that it works in the way that we need for the next ones. So if the enemy's above us, then we want to start doing the nearest enemy thing. So we are going to need these. So I'm going to put them up here for right now. And we're going to do this check here. Except for instead of it being... We're going to have to change some of the terms here. So square distance. So instead of enemy transform.position... Actually, we can do... Yeah, let's do call. So call.transform... just call it enemy. Why not? Let's just call this enemy. And then we don't have to change anything else. So, unless we're doing something with enemy that doesn't do a transform
Nearest
position.
enemy.
Okay, so nearest enemy equals enemy dot game object. So now we're checking to see what the nearest enemy is. Once we're done with that, we do this stuff. And then, so this is one iteration.
That should be out of the
Yeah.
for each, shouldn't it?
Should it be out of the 4? Yeah, it should be out of the 4 each. You're right. So this right now just is written to do overlaps here from our player position and the enemy. So instead of doing it that way, we want to... Alright, so we've done this once, so we're going to need to make a loop around this like we have here, where we have this while here. So, what I think I'm going to do is...
Change transform.position to use the beam transforms.
Alright.
Dot count -1. That way it'll use the player, and then after that it'll use enemies.
Dot count -1. Although we want beam transforms
Right.
with that as the key. So beam transforms dot count -1.
Dot.
Now we're adding the next one, so that'll work. So if we loop through this, it'll still work. So what's the conditional where we stop looking for new enemies?
If beam transforms gets to a certain
So we'll do a certain number of them or something?
number, or if they're outside of, if there's nothing in the
Overlap sphere?
Yeah, then it
Yeah.
shouldn't be trying to even find anything. At that point, it should just say, nope, no more enemies.
Alright, so what we're going to do is... I'm going to take this out of the for each statement. We're going to check it a little bit earlier. So we're going to do physics overlap sphere, and we're going to create a collider list. So collider array enemies equals that. And then what we're going to do is, instead of doing in physics overlap sphere here, we're going to now change that to our enemies. And then, so we can check now if this is empty, but we also want to check to see if it doesn't have any valid targets in front too. Because there's going to be a point where it's not empty, but
they're actually in a position behind you.
yeah.
Below you.
So then we'd clear nearest square distance and nearest enemy at the beginning of the for each, and if there's no new data in those at the end,
Okay.
then
All right, cool. So that works for me. So what we're going to do is, this is going to be our check. Actually, it's not going to be our check. This is going to be our check. If enemies dot count or dot length is greater than 0, while enemies dot length is greater than 0, we do all of this. That looks right. And then what we're going to do is, at the end of this part, if nearest enemy does not equal null, then we do this. And this might just work. I'm
we
going
have
to
null out nearest enemy.
It is being nulled out right here.
Oh, okay. And we need to do physics overlap sphere at the end of the while loop, since you took it out of the...
Well, oh yeah, thank you. Oh wait, yes. Okay, you're right.
Because it's per enemy, and that right there is just going to be for the player.
Wait, while enemies dot length is greater than 0, that's not going to work. So wait, so I'm doing this wrong. So we can't do while enemies dot length. We got to do. Oh wait, I see what you're saying. So. Okay, so we just do, at the end of the loop, we do another check here? Is that what you're saying? Or
Actually, we might want to do it in the if statement.
Oh, yeah.
And then also put an else on the if that has a break
All right.
Yeah.
for the loop.
That makes
So
sense.
else break.
Else break. This isn't complex at all. So enemies equals physics.overlap sphere. Beam transfer. The problem with this is, oh yeah, that's fine. That's legit. All right, let's see if this works. Let's just see if it works first, and then I'm gonna actually go over it over the last 5 minutes and explain what we just did.
If it works.
If it works. All right. Well, if it works once we get compiling. So, float. And test some invalid arguments. What's the invalid arguments? So beam search radius is a float.
We changed the first parameter. Is that incorrect?
Oh yeah, it is. Dot
position.
Dot
Or
transform dot position.
isn't it already a transform?
You're right. Dot position. Save. Alright, got another one. Cold does not exist in the current context. Oh yeah, enemy. I fixed it for the other ones, but I didn't fix it for that one. And Bezier laser, we're gonna do enemies.
position on the first parameter again.
Dot position. Thank you. Save. Any more? Got some warnings. Who cares? All right. So you hit play, and in theory,
We got an error.
same
bunch of
key.
errors.
Okay, we aren't
Oh,
resetting
same key.
the keys properly.
Okay.
Oh wait, that's because. Wait. Why are we getting that problem? So, element with the same name already exists. So is an enemy somehow coming in here twice? All right, let's debug.log nearest enemy. What we're gonna do is I'm gonna save this. I'm gonna pause. I'm gonna play. We're gonna pause it, and then we're gonna clear this, and we're gonna go 1 frame. All right. So enemy 1 showed up 3 times.
That is way too many times for enemy 1 to show
Well,
up.
that's not. Is it always the same enemy 1? It might not
Oh,
be.
is it finding itself multiple times? Is it not excluding anything that it's already found?
Probably not. But I mean, if it finds, like, theoretically, unless something's
It's
like
just trying
parallel.
to find the nearest enemy. Yeah.
Wait, physics overlap sphere. Are we getting the enemy that because we're giving a position, we're not giving the transform of that enemy. So is it finding itself as being the closest? No, because the y value wouldn't be greater unless you did
Yeah.
a check of greater than or equal to.
I
It's
didn't do
greater,
that.
So
Hmm.
oh, wait, transform.position.y. That should be beam transforms.count -1.
Oh, thank you. It's this one. Right here. Do we need that anywhere else? No. Save. See if that solves it. Good eye. Very good eye. Alright, so now you still have a problem where we're not close enough. That's fine.
Yeah.
So
But
what
when
we
we're
have to
close
do in
enough, it
that
actually
case-
does work. And actually, let's move these guys around to see how this goes. So we move him. If he gets out of range, he's out of range. And if he is lower than the other one, it goes to him first.
So that's an easy case to fix if you want to fix that. I mean,
Yeah, that works.
the player moves too far away. All
Yeah,
we
let's
have
do
to
that.
Is,
So, what's the easy fix on that?
maybe we can do it after. Scroll down a little bit, because we have beam transforms. Okay, so scroll down to where we're actually sending the new
Okay.
list.
Oh yeah, we can just do if.
Beam transforms.count equals 0.
Yeah.
Then pass the null list for an empty list.
If beam transforms dot count equal.
That's in a for loop, so it actually
we
is
want this
never going to
outside.
run. Yeah.
If beam transforms dot count is greater than 0.
Apparently, you can Control Shift F.
Or
to
greater than
format
1.
Code. Weird.
Greater than 0.
Why would it be greater than 0? Because the player's going to be
Oh.
there no matter what, right?
Yeah, yeah.
So greater than 1. And just tab this out so that we can not
You ever
read
tried
more
using
of this.
Control Shift F?
To format the code, I probably should. I don't really like its formatting though, so
And now put an else on the if.
I should probably change all of the settings so that it's my formatting. But put an else on the F. Oh yeah, to disable
This is
the
what
thing.
we
Yeah.
actually want to check. So
Else.
this is the part that we're actually adding.
Yeah.
Is else beam.set Bezier chain.
Dot set Bezier chain.
What's the other one? List. So
New list.
Yeah.
Cubic Bezier chain. List. Cubic Bezier chain. Or is it cubic Bezier points?
chain,
It is.
or is it points?
Points.
Yeah.
Points. And what else did it need? Did it need another thing? Yeah, it did.
It doesn't.
No, it doesn't.
That's
Perfect.
The update.
Save.
It's set to true, but if you're
Play.
actually making multiple changes, then you can set it.
Yay, it works. I would say that's a
Nice.
successful episode.
So you're going to take a few minutes to explain everything.
I was, but
In
now I
more
don't have
detail.
minutes. No, okay, I'm gonna explain it.
Next time. On
No,
Cooking
that'll never happen. So, all right. So, what are we doing now? So, we aren't even using all enemies anymore. I don't think. Let me just delete this and see if it still compiles, because I might just eat my words on that. I did. All enemies removed nearest enemy. We don't care about that. Save.
We're using it, but we shouldn't be.
All right. Play.
And
All right.
all
Everything
enemies
seems
is
to still work. All
all
right.
enemies is global, isn't it? So you can remove it there.
I think I just got rid of it. I think there's no more all enemies. Yeah, they're gone.
Oh, okay. It was the local.
It was local, yep. So, beam transforms not clear. So this clears our list of transforms. Enemy distance clear. This clears our dictionary of enemy distances. So there is nothing in either of those lists or dictionaries. We immediately add our player.
Mm-hmm.
We do our initial check of physics overlap sphere based on the player position, which we could have just put transform here, considering we duplicate it here, but this allows the term to be exactly the same because we've already added it to our list. So our list will contain exactly one thing, and the count will be 1, and so we'll get element 0, and we'll get the position, and we will do a physics overlap sphere. So then everything within that physics overlap sphere, we go through, and we so we create a new so this is each iteration here for each, not for each enemy, but like
For each thing it finds, and
yeah, so
in the overlap
so
sphere.
yeah, so if we have enemies in our overlap sphere for the last call, we continue through this. So we have our nearest square distance. We set it to mathf.infinity because we're going to be checking for things that are closer than infinity theoretically. And so every time that we add something to this, it'll be a closer value. And then we have our nearest enemy, which contains whatever our nearest enemy once we check that. So right now it's null, right now it's infinity.
this is very similar to finding a heuristic for A-star pathfinding.
Yes. So we have a for each loop here. This is each enemy and enemies. Enemies, again, is whatever was in our overlap sphere. So we have our enemies. If the enemy is higher on the screen than the previous thing's position on the screen, so the height is Y, then we check to see its distance. So we do that. This is just the distance calculation of the enemy to the previous thing. And then if it's less than our nearest square distance, which the first time it will be, and then subsequent times it may be, we set that and we set the nearest enemy. So by the end of this for each loop, we have the nearest enemy that was within that sphere. So now if we have a nearest enemy, which is possible there could have been nothing in the sphere or nothing that's above us in the sphere, but if we have a next enemy, we add the enemy and its distance, so that we can check that later into this list. We add it to our beam transforms, which is our list that we use just for... We probably don't need... No, we probably do need both of these. Okay. And then we set our enemies to be a new physics overlap sphere. So this is where at this point it would loop back up to here and do it for the next group. And then again and again and again until it's done hitting enemies, or until something's out of range. And then the moment that it doesn't do that, the moment that we don't have a nearest enemy that's in our range, we do a break, which gets us out of the while loop completely. And we immediately continue on and actually check all of this data and then apply our positions appropriately. We did this on the last episode. I'll go through it. Why not? It's only a few minutes. So beam transforms.count is greater than 1. So if we have something that's not just our player in the list, we go through, and for each thing, if we have an enemy in there, we we get the distance information, and then if we have the distance information is just used in our equation here. So this just says our current position, the midpoint plus a random plus a craziness value plus the distance, or times the craziness value times the distance. Same thing for the other point, which just puts it into another random position. And then beam transforms I plus 1 dot position is the final point, which will correspond to the next thing. And we do +1 here, and we don't have to do a -1 because we already did our -1 at this point on the for loop.
So I noticed something we should be doing a bit differently.
Okay.
We can actually take that if check that we added out, because beam.setBezier chain shouldn't be in the for loop. We should be setting the chain after we've gone through and set all of the points correctly. Right now we're setting
we're
the
doing
chain
this
after every
frame.
single point.
Yeah.
So, and once we take that out, then we'll, if it doesn't go through here, if it doesn't go through that for loop, it's because there's nothing in there, and the new list that we set before the for loop will have the same effect of the if else that we.
Okay, so you think this will just work without the if else?
Yeah.
I don't really see how that's possible, but let's okay, I'm going to go with it. So we're going to get rid of, I'm just going to comment this for a moment. See, we're doing code now, and I wanted to be discussing this, not changing it, but okay. And we don't need this if statement?
No.
All right. And so this just should automatically work now for some reason?
Well, because before it didn't work because we were only setting. We were doing two things that were kind of.
All right, let's see what this does real quick. I'm just curious. Yeah, you're right. Totally works.
We were doing two things that are cleaned up now. One, we shouldn't have been setting the chain every frame because we weren't actually done creating the chain. And two, the reason that it wasn't going away is because it doesn't get into the for loop. It doesn't do this. If it
so it had the previous Bezier. Okay, so it didn't
because
reset
it was never setting the chain.
Got
but
it.
now that it's outside, it sets the chain either way, and the new list at the beginning.
So so what happens here is if we only have the player in here, beam transforms that count -1. This won't actually go in, and so we'll just immediately set beam chain to be it's null at this point. It's just a new list that's empty. And then otherwise we go through and we add all the points for the player for the different enemies that we went through. All right, that's good enough. That's good enough. So let's quickly. I'm gonna save the scene, save project.
We need to change the color
Quit.
from pink to like white, maybe
That,
with a hint
that
of
can
blue.
be next
And we're going
episode
to do
project, I'd
reconcile offline work.
say. Right?
Yes.
It'll change the color of it.
So we didn't get to
Create
options
maybe
or
an
other
option,
things, but
which
yeah,
would be really, really cool, actually.
yeah.
Didn't get to what?
We didn't
Create
get to
options.
create options or the other things I listed. I should have just said beams because I don't know, but we got this going, so that's great. We're set up clean slate for next episode.
Yeah.
So beams totally work. It's awesome.
We can add some color or some effects to the beams, and we also need to apply damage.
Yes.
Damage is overrated.
All right. So
And we could also add a key that actually fires the beam as opposed to having it run the entire time.
thank you guys for joining us tonight. Oh, it's doing that again. Oh, okay. Whatever. What's wrong with you? Oh, that didn't help things at all.
I don't know.
All right, whatever. Thank you for joining us tonight. If you have any questions, please email me at pushypixels@pushypixels.com. You can also tweet me at Drakfire, DRAKFYRE. And you should buy Phil's game, Robot Alone. And it's on iOS. It's fun. It's a cool game. It's like Puro.
Yeah.
You should play
Puro
it.
2.
Puro 2, yeah.
And you can send me an email if you want to. That's Philip at protosoftworks.com, or you can follow me on Twitter at magmalemur. You should also donate to Cooking with Unity. Do it. Donate.
Yep.
Don't
and
delay.
Donate stuff
Donate.
still hasn't been sent out. I'm sorry I got hit with work again, but I will. Maybe tomorrow. I want to get it in this week. I really do. Anyway, did you have anything you want to say or anything?
I did not.
All right, cool. We're done? Okay, we're done. Thank you for joining us. You guys have a great night.